Hey everybody, today we will do another math problem. Actually, electrical. I mean, it's mathematics, and so unfortunately, I'm sorry. Um, so so we will do another case. I think maybe one or two cases of that problem that we had in last video. So um, so the figure is like this. So we got 24 volts. 24 volts, and we have a resistor, and then connected to that resistor we had an inductor. So we had an inductor, and that was I believe it was 1 Henry, and we had a capacitor, right? And we have a capacitor. Oops. A capacitor like this, and then from here we had a switch, and that switch is like this. So we had a switch like this. So at some moment this was like, actually I think was the other way. No, actually it was this way. So it was like this. So it's another terminal point right there, and it was like this. So, and then we had a one resistor right here. That is 1 ohm, and this is 1 ohm, and this is 0.25 farads, and this is the one that we're changing now, right? So the value of this, instead of being 5, now is 4. In the last video was 5, now it's 4, and we will see how that changes when we do the problem. And that is the whole purpose of doing this video, because I want to show you another case. So okay, so let's get it started, right? So the first thing that we need to do is the same thing that we did last time. So what did we do last time? So we found the current, right? We found the current, assuming that at the time equal to 0, t is equal to 0. At that moment, when the switch is still closed. So you see, like, this guy is not even here, right? Because it's acting like an open circuit, right? So what we do, and then we take this guy as a short circuit. So this guy has an open circuit, this guy has an open circuit, t is equal to 0. We're just dealing with these two guys, right? And I think you understand that. I mean, I can rewrite the circuit and say, okay, so replace, we can, just to have a better understanding, we can say, okay, so this is a 4 ohm resistor, and this guy becomes a short circuit, all right? And this right here the inductor becomes a short circuit, and the capacitor, because t is equal to 0 at that point, that means that this has been closed for a long time, so it's closed, so that means that it's not even count. So basically, we replace that as an open circuit, and we have something like this. So I want you guys to understand this because it's very important, right? So we have something like this, right? So now at this point, this is basically, the current is going around like this, right? So the current is just going like this, right? It's doing, this thing. It's going around the circuit because there's nothing preventing this from this, right? So it's time equals 0, all right? So hopefully we get an idea. Now, with that being said, right? So we have this guy that is right there with this. So basically we need to find the current at t is equal to 0. So at t is equal to 0, so I at 0 is equal to what? Is equal to V initial voltage, which is this guy. You can call it BSS, right? B is steady state, divided by the current the case that we're studying, which is that one, plus the other resistor that was previously there. So we do what? We do 4 plus 1, right? And then the top one right here is 24. So 24 volts divided by 5 volts is equal to 4.8 amps, right? 4.8 amps. Okay, so we have that, right? So I of 0 is equal to 4.8 amps. We need that number, right? We write it down. Now the next step is going to analyze this. At the time that this guy is equal to 0, right? And this guy is acting like an open circuit. What does that mean? So you take the voltage meter, put it right in this point, it's going to look at what is going on in that resistor, right? So now what happened at that point? We can say that V R1 is equal to VC, right? The VR1 at 0 time is equal to that VC, right? So now we can say that VC is equal to what? Is equal to R. You can call this, you can call this R, maybe R1 or R initial, whatever. This is what was already here. The one that we're changing is this. So you can say that BC is equal to B is equal to R. Put R1, right? Representing that this R is right there times I0, which is the 4 amps, 4.8 amps. So VC, V at the capacitor, is going to be equal to this guy, which is 1 ohm, times 4.8, which is 4.8 volts. In this case, right, so we have a similar case that we had last time. So VC, right, VC at 0, we can say that because it is the voltage that is being seen at this, right, at that moment is actually 4.8 volts. Okay, now we got that, right? So now we're ready for the next step, right? So now we say that we can say that V at 0, right? V at 0 is equal to 24 volts, right? Plus the rest of it, right? We can say that. Now we're going to start working this out. We can start working this out by doing the following. So okay, so now we can find the rest, right? The rest of the stuff that we need to find, right? And how we do that. Okay, so that's the question. How do we find the rest of the stuff that we need to find? At the moment, the way that I have it right now, basically we have, let me just do this for a little room right here. So we need to find, okay, so let's do the next step. So we need to find alpha, and alpha is going to be equal to R over 2L, which is going to be equal to, in this case, is 4 divided by 2 times 1, and is equal to 2, right? So alpha is equal to 2, and then omega is going to be equal to over 1, so 1 over the square root of R of LC, which is equal to 1 over the square root of 0.25 times 1, which is equal to 2. Now, if we think about it, now omega is equal to alpha, right? So we have something right here. So, but we can say that omega naught is equal to 2, and alpha is equal to 2. Now, we have this, that also numbers that we need. Now, what is next, right? So we have something. So next is going to be, to write this equation, right? So we need to find S1. So S1 is going to be equal to, if you think about this, about with what we learned last time, you should be analyzing that already, of what is going on, right? So S1 is equal to is equal to alpha, right? Is equal to alpha plus or minus okay, alpha is equal to plus, is equal to negative alpha plus or minus the square root of alpha squared minus omega squared, omega naught squared. Now, so S1, right? S1 is equal to minus 2, which is that 2, right? Minus 2, and then we use the plus sign right now, and we get 2 squared minus 2 squared, which technically this is equal to 0, so we just left with S1 is equal to negative 2. Okay, so negative 2. Now, if you think about this guy, right? So if they are the same, that means that the second one, S2, this is not going to change, it's going to stay the same. So the only thing that will change the sign, but not going to make any difference. Okay, because it's going to be minus 0. Minus 0 plus 0 is the same. So it's going to be, so this S2 is going to be negative 2. Negative 2. So they both the same. They are both the same. Now, what is the case now? We have a situation where S1 is equal to S2. That means that we have similar roots, right? In mathematics, it's called an extraneous solution. But in this case, we don't call it extraneous solution. We call it, because it's engineering, we call it critical depth. Right? Critical depth. That's what we have. That's that's the case that we have in this case. Now, how do we write this equation, right? So that's another case that we need actually, and we learned this in differential equation because it's part of it. But what we do right now is that instead of having something like this, so we do have like something like this. So B of t voltage, right, is going to be equal to, of course, is going to be equal to 24 volts, right? 24 volts, but we have a plus something, right? And that plus something is going to be A1, and then we have a plus A2, with the only difference is that we add a t over here because the roots were the same. Because the roots are the same, right? S1, right? So we had a S1 was equal to -2, and S2 was equal to -2. So in this case, we just add a t in front of it, and we call this, put parentheses, and multiply that by e to the -1, because this is S1 and S2 are the same, so we pull 2t. So you can see that is the equation now, right, at the moment. So we have one equation already now. So now we say that we evaluated a v is equal to 0, right? A v is equal to 0. We found that is when t is equal to 0 in this equation, we found that is 4 volts. 4 volts. We found that, right? So now, let's say, for example, now we want to change this guy, right? Put 0 in there. And put a 0 in here, whatever you would do over here, you gotta put everything in there, right? Now, what is the voltage at that? We found it. Now, what we do is 4.8 is equal to what? It's equal to 24, the initial voltage, steady state voltage, plus A1, right? Plus A1 and A2. Plus A1 plus A2 E T, right? Don't forget the T, right? T E. Let's see. Okay, now, so let's do this, right? Why not? Let's plug in whatever. Put a T over here. Put 0, right? And then right here, just put 2 times 0, right? Now, you can actually do this different ways. You can actually multiply this guy across, right? But this across, because you already have a 0 here, this is going to be equal to 0, this is going to be equal to 1. E to any number is 1. Sorry. Nope. E to any value of 0, right? So, well, I guess the value of 0 is always 0. Okay. But so e to the 0 power is always 1, right? It's always 1, right? So now you do this. When you do that, you see that you have a 4.8 equal 24 plus A1, right? Because this, it's gone to 0, because you have a 0 right here, right? Well, no, let me just correct myself, actually. This is 0, right? This is 1 right here. So you keep the A1, so that's why you get this. Now, you subtract 24, and we get that A1 is equal to negative 19.2. That is the value of A1 right there, right? So we have an A1, okay? Now, you find A2? How do we find A2? So A2, we have this guy right here. So we need to do something with that. We need to do something with that, right? So now, so now what we do right here. So what we do is the following. So we take the derivative of that guy. Take a derivative of that guy. And that's how we do that, right? So when we take the derivative of that, because you know that v of t is equal to this, so we know that v of t is equal to that, right? So it's equal to 24 volts plus A1 plus A2 t, right? E to the 2t, right? Now, taking the derivative of this, right? So now what we do is take the derivative and say dv dt of this guy right here is equal to 0, so 0, right? I'm not going to write anything, but I am going to do something right here. So to simplify things around, I'm going to multiply that. So you guys are not really familiar with calculus yet, even though we're doing some advanced stuff, you will be able to get familiar with. So multiplying this guy right here is equal to A1 e to the 2t plus A 2t e to the negative 2t. Now taking the derivative of this. So I have not taken the derivative yet. I am going to now. I just multiplied this, but I just cancel that because that is the derivative of that is equal to 0. So I don't even have to do it. So what I do is dv over dt again. Well, not again because I have not taken the derivative. I just did the operation. I don't want to get you confused. So now taking the derivative of this guy comes up front, right? And it's equal to what? Is equal to what? That is equal to negative 2 that comes with the front, and A1 e to the 2t e to the negative 2t, right? And then the same thing over here. That guy comes up front. It's going to be negative 2 A2 and then t. You gotta be careful over here. Very, very careful. Because see, right here we have a term. We have a t. And we're taking the derivative with respect to what? Respect to t. Respect to t. So when we take the derivative with respect to t, we take the derivative of this guy, right? We bring this to the front. We use the power rule to bring this in front. But we use the product rule to do this part. So what we do, we bring it in front and we say e to the 2t, right? Now once we get that, we do the rest. So now we do this part. Now remember, okay. So let me just do this step by step because it's so t. I keep my t. Now I say plus, right? I am using the product rule. The derivative of the second times the first plus the derivative of the second times the first plus the derivative of the first times the second. So now I am doing the first, right? Now the derivative of the second times the first plus the derivative of the first times the second. So now what we do is take the derivative of this. So plus the derivative of the second of the first times the second, right? So now we do 1, right? But of course the derivative of that is 1 times what? Times e times e to the t. Now, what is this? So basically, this dv dt, and then this is going to be equal to what? This is going to be equal to 2a1 e to the 2t, right, minus 2a2 t e to the 2t plus. But remember, we're scattering that one. That one is a constant, so I need to still keep it over here. So I need to just keep it over here. A2, right? I put that A2 right here, plus A plus A2, right? So plus A2 times E to the 2t. Now, so let me just write this. So A1 is equal to negative 19.2. This is another number that we have to kind of keep it in mind because we might use it. We probably will have to use it. So, okay, so now, if you think about this, you can factor out the whole thing and just keep it this terms inside. So you can factor out the whole thing. So we can say that dv over dt is equal to negative 2a1 plus, nope, minus 2at. I keeping that t in there, but it's this a right here, this a right, a2t, and then now there's a plus this guy, which is a2, plus a2, and then everything multiplied to that. Right? So we factor out e to the e to the negative 2t, right? So now we have that, right? So what is the next step? Next step is to simply say that the derivative of 0 is equal to that, right? So the derivative of 0 is equal to that, right? Okay, so now we can say that the derivative of this evaluated this as 0, right? So what did we have? Evaluated this guy at 0. Evaluating this guy at 0, we had 19.2, right? We had that for when we did the calculation. We had 19.2, and I think I erased it, but it was negative 19.2, I believe it was, because I subtracted to the other side. No, it was positive. Let's see. let's see. Just erase this. I don't need this anymore. Okay, so okay. Yeah, because what happened was that dvdt at the moment where okay, so what happened is that when you do this, right? So we had a derivative of, we found that at v of 0, it was 19.2, right? Which is technically similar to that number. The only thing that we manipulated in order to get that. So at that point, we say that okay, so if that is the case, then the voltage, because the voltage difference of this, right? The voltage difference of this, of 24, okay, let me just be clear. So 24 minus 4.8 is equal to, I don't want to confuse anybody. That's the listing that I want to do, right? So that is equal to, that is equal to 19.2. Okay, I don't want to confuse anybody there. So, okay, so the voltage at this, right, at v of t is equal to 0 is equal to that, right? Now, at the time equals 0. Okay, so now what we do, we say that, okay, so we say, okay, so now having this, we say dv, right, at t equals 0, dt, okay, the change in voltage is 0. Is 0 at time is equal to 0, right? Is equal to 19.2, which is equal to what? Which is equal to this guy. So which is equal to negative 2a1, negative 2a2 t, right? But assuming that we taken at the time is equal to 0, we said, okay, so we say that forget about this, just do a1 and a2, right? And we just get rid of that. Okay, now having that in mind, okay, let me be clear on this, because it can be confusing if you, okay, so we know that it's equal to 0, right? So now what happened when I substitute 0 for this and I multiply times this? This is going to be just 1. This is going to be go away, right? So let me just do it. Just do it, because it can be confusing. So okay, so dv dt, right? So now it's equal to what? So everywhere I see a t, I'm going to replace by 0. So negative 2 A1 minus A2, then 0, and then plus what? Plus A2, and then e to the 2, 0, right? Well, this is equal to 1. This is going to be equal to 1. 1 times this is going to be 2a. Times this is going to be 0 because there's nothing there. And times this is going to be nothing but negative 2a because that is 1, right? So now we have 19.2 is equal to what? Is equal to negative 2a plus what? So just to be clear right here. So this is equal to, so dv of 0 over dt is equal to negative 2a1 plus a2, right? So plus a2. Okay, so now if you think about it, now we had a1, a2. Now we had another a1 right here. Going back and refreshing our system of equations back in the days math, right? We can put this guy and this guy somewhere over here, right? And we put 19 is equal to a1, right? So now think about this. This 19.2, right? This 19.2 and this cancel out, right? It's gone. Now this one and this one, adding those two is equal to 0, right? 0 plus 0, and then adding this 2 is equal to negative a1 plus a2, right? Now solve it over here. What are you going to do, right? Solving this to the side, it's going to be a1 is equal to a2. Now, well, I mean, assuming that you have the right thing, well, I think you can figure out that if a1 is equal to a2, then this guy a1 is equal to also 19.2, right? But if you don't believe yourself in this case of a1, right, is equal to a2, then you can do the math and figure it out. That's a good thing about mathematics, that you check yourself. If you doubt in something, okay, so what you can do is the following. So a1, right, so we have 19.1, negative 19.2, right, is equal to, okay, so let's use this one. Let's use that one, right? So what is the number for that? That was a negative. That was a positive, right? So 19.1. That was 2, right? Negative a1 was equal to 19.2 plus a2, right? And this guy was a negative. This guy right here was a negative. So what do we do now, right? So 19.1, right? So now if we do this is negative. So this is negative. So now what we do? So we know that a1 is equal to that guy, right? We know that. Now let's do the mathematics and see what the heck is going on here. So we have 19.2 is equal to what? Is equal to negative 2 times what? Times the negative 19.2 plus a2. When you do this guy, is equal to 19.2 is equal to 38.4 positive plus a2. When you subtract this to the other side, you find out that A2 is equal to negative 19.2. If you will trust yourself, you will figure that you will just trust in that, and okay, you will say, okay, they are both equal, right? But if you don't trust yourself, then you check yourself and you figure out that A1 and A2 are the same. Okay. Okay, so now we found out that A2 is equal to 19 is equal to negative 19.2. So, okay, so A2 and A2 and A1 are the same, right? So hopefully 0.2. Okay, so now almost there. Okay, so okay, so how we can write this, right? So we need to write the equation. Okay, so B of t is equal to B steady state plus that, right? Like the one that we had. So B of t is equal to B steady state, which is 24 volts, plus negative, right? Plus negative was plus A, right? But in this case it's negative, so negative 19.2, right? Plus A2, right? But it's also negative 19.2. But then we have T, right? But then also we have this thing, the whole thing being multiplied by something, what is called e to the 2t. Okay, so now what do we do? Okay, so basically what we can do is just factor out negative. So B of t is equal to 24 minus negative 19.2, right? Parenthesis inside with a 1, right? Plus, just leaving the t inside, t times e to the minus t, the negative 2t, right? So that will be, right, the most simplified equation for that. And that is one of the solutions actually. Okay. Okay, so now let's do the rest. So that was one of the solutions, right? So that's one of the solutions. Now we know that I of t is equal to c dv over dt. I of t is equal to the capacitor multiplied by the change on the voltage. Now what we did, we found that it was idle 0. When I was 0, we found that was 4.8, right? So 4.8 is equal to c dv over dt. Divide by that, and we see that dv over dt is equal to divided by c. I don't want to just get confused, but divided by c, and we see that the 4.8 over c. Okay, so now at that point, so we say that 4.8 over 0.25, I believe it was. So 4.8 divided by 0.25, 19.22. Same thing. It's no different. I mean, it's just this. In this case, just these numbers are matching up, right? So that's the whole thing. That's what I'm trying to say. 19.2. Right. So dV. So dV over dt, and that is volts. I'm sorry, it's volts. Okay, so okay, so we know that, right? Now, what we can do here? So what was dV, dV over dt? So we found that, just to prove it, we found that, right? So now let's we proved that part of it. That was true. Now we're saying that dV over dt is equal to that, right? So, and then what we do is because I of t is equal to c dV over dt, dV over dt, because of that we have to multiply the equation, and we have to multiply the equation that we found, right? Which in this case was dV over dV over dt was equal to negative 2a1, and then minus 2a2, and then t, and then times a2, right? So then everything in this case right here was e to 2t. But what will we do? That's the question, right? So that means that we need to multiply by c. Why? Because this is what this is, right? This is what this is, and this is the value of the capacitor. So we need to multiply the value of the capacitor by this. Okay? And when we do that, we found that now, but you think about this is the current. That's what I'm trying to find right now, right? So technically, what I will do is just multiply, just multiplying everything by this guy. So technically, what we can do is just replace that by IC by I of t, right? Just because I'm multiplying this, like this. So now what we do is what? I of t is equal to 0.25 times negative a1 minus right, minus 2a2 times 0.25, and then plus 0.25 times a2, and then e to the 2t. Okay, so with that being said, now the last step is to replace every single one of this. However, I gotta be careful. I gotta be careful here. So it's a to t. Okay? A to t. That t has to be there. Okay. So when you do all this, right? And you find out that by replacing everything here, you find out that now what I had to do in this case, okay, let's do it. So if I do this, I have to get rid of that circle because that's covering space. Okay. So I just wanted to do a step by step so we learn about this. So let me just write this answer here. It's B of t is equal to 24 minus 19.2 times 1 plus t e to the 2t. Okay, that's the answer. So now that I have that, we can use this space right here. Okay, so now multiplying this. Okay, this is equal to 0.5. That is equal to, also this is equal to 0.5. That is equal to 0.5 t times the A2, right? So okay, so we do so 0.5 A1 minus point minus 0.5 A2t, right? Plus I of t is equal to that, plus in this case it's going to be 0.25 A2, right? And everything to the t. Okay, so and notice that everything right here is to that, right? So now what I do, right? So I say that, okay, of t is equal to what? Is equal to 0.5 minus 19.2. That's the value of this, and then times minus, right? And then remember that this guy was a minus, so I gotta keep that a minus. Be careful. It's very dangerous to make a mistake over here, and then a sign will throw you off the answer. Okay, so it's negative, right? So that is a negative, so it's equal to a positive, right? And then this guy right here is also a negative, so it's going to be equal to 0.5 negative 0.5 times 19.2, and of course you have to put a t in there, and then this guy stays a positive, but this guy is a negative, plus 0.25 times negative 19.2, right? E to the 2t. And remember that the e to the 2t are just doing it. You can actually bring this eventually. After you've done this, you can, but that's being just me multiplied by the whole thing. You can actually do all this and then just remember that you have that and attach that to your answer. You don't have to do it this way. So I of t is equal to, right here, it's going to be equal to 9.6 equal to 9.6. So this guy right here is equal to 9.6, right? And it's positive, right? And then this is going to be equal to 9.6, and also positive. Yes, positive, right? And then, but it's t, right? T is belong to this guy right here. Now, this guy right here is equal to plus 4 point something. Let's see. 4.8. Okay, so this guy right here is 4.8 and is negative, right? So that guy is negative, right? This guy is negative, and then this e to the 2t. Okay. So now e to the 2t. Now, if you think about it, what are we doing, right? So now you do so now in this case, let's see, that's negative. So you add this to this, it is 4.8. So it's 4.8. So this is equal to 4.8, right? And now what you do is just add this to this and this, right? So now you got that I of t is equal to 4.8. It is positive because this was negative, and then over here you get what? You get plus plus 9.6t, right? Now, I mean, you can factor more, but yeah, so I mean, you can factor this even more. I mean, this and this, you can actually divide that by 1 and that by 2, and then you will have it just basically 2. Yeah, you can factor it, you can leave it like that too. Right? So now, pretty much that's it for that problem. I mean, and then so we have the other answer, and then we have that one. I of t is equal to 4.8 plus 9.6 t e to the 2t. And those are the two answers. So that's one. And this is the other one. So that's what two answers. So I hope you enjoyed this video, and I see you in the next video. Thank you for watching.